On Friday, we spent a lot of time solving equations. We talked about the sibling rule. Our goal is to get the variable by itself. What we do to one side, we have to do to the other. We talked about inverse operations. Okay? Now, we are going to use all of those properties to solve for specific variables when we have more than one variable. So in this situation right here, I have x plus y equals 13. When you are solving for a specific variable, the problem has to tell you what variable you're solving for. So if it just says solve, you're like, I don't know what to solve for because I've got more than one variable. Now, in this situation, I'm solving for y. So what do I need to get rid of if I'm solving for y? The x. So what I'm going to do is I'm going to subtract x from both sides. Okay? So when I subtract x from both sides, I'm left with y equals negative x plus 13.
You also wrote 13 minus x.
You could write 13 minus x. Yes, that's completely fine. So it is okay to have y equals 13 minus x. Thank you for pointing that out. It is okay to have 13 minus x. Any idea why my first habit was to write it as y equals negative x plus 13? Any idea?
Isolate the variable.
Okay, and we did isolate the variable. Good. What form is y equals negative x plus 13 in?
So you make sure that the sign change after it goes past the equal sign.
Good. Okay, and we did. We made sure. Yes, you're absolutely right. We had to make sure that x became negative x on the other side. Does anybody recognize that form?
Isn't it a linear equation?
It is a linear equation. Yes, you're absolutely correct. So my habit, my go-to was y equals mx plus b. But you are 100% correct. So thank you for pointing that out. It is 100% correct to write it as y equals 13 minus x. Good. And the reason that I start with x and y is because we will do that when we're graphing linear equations. Excellent job. Okay. This one, we're doing the same thing. We are solving for y. So the first thing that I'm going to do is I'm going to subtract 2x from both sides. Okay? I'm subtracting 2x from both sides. Now, I want you to look at that minus sign right there. Who does that minus sign belong to? The 5y. Okay, so we've got to keep that minus with that 5y. That is a common mistake for students. Now, I am going to write this as minus 2x plus 7. But as we just talked about, if you wanted to write this as negative 5y, 7 minus 2x, you totally can. Okay? They mean exactly the same thing. What you need to look at is, where is the minus here? What's it in front of? 2x. What's it in front of here? The 2x. Okay? So as long as you've got that negative sign accounted for, you're in good shape. Now, I'm going to divide everything by negative 5. Okay? I'm dividing everything by negative 5. When I do that, I end up with 7 over negative 5. And then I have negative 2x over negative 5. What happens here? What happens right there? They cancel or it becomes positive. Correct. Okay? So I'm left with y equals negative 7/5, and you can put that negative wherever you want to, plus 2/5 x. Now over here, you're still going to end up with the same answer even if it's in a different order. You're going to have 2/5 x minus 7/5. As long as your negatives are in the right place, it doesn't matter which way you write it, because we're not being asked to put it in slope-intercept form. Okay? We ready to? Yes.
I'm
trying to figure out a word to, or a way to word it.
Mhm.
The reason why you didn't like subtract 2x from 7 was because it has a. Okay.
It's called unlike terms.
Okay.
Okay? So the reason that I did not subtract 7 or 2x from 7 is because 2x and 7 can't be combined. They're not like terms.
Okay,
Good
I'm
job.
just making sure.
Excellent. Excellent job. Okay, can I go to the next screen? Okay. Now we are solving for W. Now we're solving for W. I have P equals 2L plus 2W. I've got to, before I can get anywhere near the W, I've got to get rid of the 2L. How do I get rid of the 2L? Subtract 2L. Okay, so you're going to subtract 2L from both sides. Okay. So now I've got P minus 2L. Now what do I want to do?
Divide by 2.
Excellent. Divide by 2. Excellent job. I usually stop right here. So I would get P minus 2L over 2. There's really not any reason to go further than that. However, I do have some students that do. And they would have P over 2 minus 2L over 2. The benefit of going that additional step is what can I do with the 2 and the 2? I can cancel them. Okay? And so these would cancel, and I'm left with P over 2 minus L equals W. Both of these are 100% correct. Both of those are correct. Okay? Yes?
So is the one that we're solving for is what we divide by?
The number with it, yes. So we were solving for W. So we divided by this 2 because 2 and W are being multiplied together. And so 2 times W, we're doing the inverse, which is divide. Excellent, excellent question. Okay. Now, the next one is the area of a rectangle. Not a rectangle. It's the area of a triangle. I'm sorry. It's the area of a triangle. So I have the area of a triangle equals 1/2 the base times the height. And I am trying to find H. So I am solving this for H. Now, I want us to think about our properties of fractions. If I have 1/2 x equals a, okay? 1/2 x equals a. The operation between the 1/2 and the x is multiplication. Okay? That's multiplication. What's the inverse of multiplication? Division. So I need to divide both sides by 1/2. Okay? I am dividing both sides by 1/2. This line right here means divide. Now, so I have a divided by 1/2. I just rewrote that in a different way. When I am dividing by a fraction, I do keep, change, flip. So when I am dividing by a fraction, what do I do? We don't want to change it to decimals, okay? And in this situation, the decimal probably would work because it's 0.5. But like if you've got 2/3, it gets really icky. So I wouldn't do that. I'm dividing by a fraction, so instead of dividing by a fraction, what do? Multiply by the reciprocal, okay? So a divided by 1/2 becomes a times 2/1. So what I want to do in order to get rid of this 1/2, I need to multiply by its reciprocal. That's what I need to do. Now, if I multiply the right-hand side by the reciprocal, what do I need to do to the left-hand side? multiply by the reciprocal. So I'm going to multiply this times 2 over 1. So I have 2a equals b times h. So that just got rid of my fraction. That got rid of my fraction. Now, I'm solving for h. So what do I need to divide both sides by? B. Okay? So 2a over b equals h. 2a over b equals h. Okay. Can I go to the next screen?
I know a little bit.
You got, 2A.
Okay. So your question is, how did I get 2a? Is that your question?
No, I see it now.
Are you sure?
Yes, ma'am.
Okay.
I have that question.
Okay. Thank you very much. How did I get 2a? Okay. So here I'm dividing by 1/2. Okay. So I've got 1/2 x. I want to divide both sides by 1/2. Okay. So I have a divided by 1/2. Whenever we divide by a fraction, we have to multiply by its reciprocal. That's the definition of dividing fractions. Okay? So once I change a divided by 1/2, it becomes a times the reciprocal, which is 2 over 1. So what I did, in order to get rid of this 1/2 right here, I multiplied by 2 over 1. So 1/2 times 2 over 1, that cancels out and I'm just left with 1. So that's how I get rid of everything on the right-hand side. Because I multiplied the right-hand side by 2 over 1, I have to multiply the left-hand side by 2 over 1. Okay? And that's how I got the 2a. It's called this. I call it the sibling rule. You have to do both the same thing to both sides. So it's easier to multiply by the reciprocal of a fraction than it is to divide by a fraction, because dividing by a fraction, you still get to multiplying by the reciprocal. I know that's a little difficult to wrap your mind around. It's a great question. Okay. This one, students look at it and they're like, oh, that's so easy. Okay? But it's actually not. So this is A equals P plus PRT, and we're solving for P. Okay? This formula, it's actually a simple interest formula used in banking and finance. It's so incredibly simple, we don't use it anymore. So we use a much more complex, we compound interest continuously now. So, but for this one, we want to solve for P. The number one mistake that students do here is they're like, oh, cool. Here's a P right here. I'm just going to subtract PRT from both sides, and I'm going to get A minus PRT equals P. And I have solved for P. That is the number one thing that students do. Okay? And it is incorrect. Why is it incorrect? There's a P on both sides. Yeah, there's a P on both sides. That's exactly right. Okay, and we can't do that. That's like having an X on both sides. We can't do that. Now, if I had something like 4x equals 2x minus 3x plus 8, what would I do with that 2x minus 3x? I'd add them together. Okay, they're like terms. I'd add them together. In this case, I would subtract. Okay, I can't do that up here because I've got P and then I've got PRT. So they are not like terms. So I can't do that there. What I have to do is I've got to use distributive property, but you're not going to think of it as a distributive property. So if I had P times 1 plus RT. And I wanted to distribute that P. Okay? What's P times 1? Okay, what's P times RT? Okay, now, think about 4x plus 8. What is common to 4x plus 8? What goes into both of those? 2, and something else does too. 4. So I could take out of 4. That's called factoring. 4 times what gives me 4x? 4 times what gives me 8? Okay. I have used the distributive property in both of these. That's the distributive property. What I did here is I just did it in reverse, and I factored out what's common. We are going to factor out a P because that is what's common. So I'm going to take a P out. P times 1 gives me P. And P times RT gives me PRT. I haven't changed the value. That's the same thing as factoring out a 4 down here. I took out what was common. Yes? It is still there because if you multiply P times 1, you would get P. So this P is just being multiplied to both of these. So I've just factored it out so that I've isolated it. Okay, Terrence?
So we factor it out to where we isolate.
Yes, that's how we isolate it, is we factor it out. Yes, that's exactly right. We isolate it by factoring it out. Okay, now that I've got that, question? No, okay. Now that I've got that P by itself, what operation is happening right here in between the P and the parentheses? Multiplication. How do I undo multiplication? Okay. And I want you to go ahead and get in the habit of putting parentheses around that. It will help you later on. Okay? If you were to write it like straight up and down, and you had A over 1 plus RT equals P, that's a perfectly fine way to write it because the fraction bar is a grouping symbol. If you like to write it at a slant like this, if you like to write it like that, the way that this is written right here is you are only dividing A by 1. And you would have to have that in parentheses. So I tell students to go ahead and get in the habit of putting it in parentheses. Go ahead and get in the habit of putting it in parentheses. Okay? That's as bad as it gets. It's as bad as it gets. Can we move on to inequalities? Not yet. Okay. We good? Okay. Okay. Now we are moving to inequalities. Now, inequalities are very much like equations. We treat inequality signs very much the way that we treat an equal sign, but we do have one exception on something that we have to do when we divide. We're going to start by figuring out what the number line means. This says to graph x is greater than 3, and then you are going to write your answer in interval notation. So we are going to graph it first, then we are going to write our answer in interval notation. Now, if I tell you I want you to pick a number, and that number that you're going to pick is x, and it's got to be greater than 3, can you pick the number 3? If I tell you that your number has to be greater than 3, can you pick the number 3? No. Okay? Because it's got to be greater than 3. Okay? Now, if I tell you I want you to pick a number greater than or equal to 3, can you pick 3? Yes. So, I want you to think back to high school. Do you remember the open dot and the closed dot? Open dot and closed dot? Okay, the closed dot we used for greater than or equal to and less than or equal to. That meant the number was included. Okay, the number is included in your answer. The open dot means the number is not included in your answer. Now, in this situation, I'm going to start right here at 0. Okay, 0 is right here, so that makes this 2 and this 4. I'm at 3. So am I going to have an open dot at 3 or a closed dot at 3? Open. Good, because I've got the greater than sign. Then, am I going to go to the right or am I going to go to the left? Good, I'm going to the right because it's greater than. Okay, now I'm going to introduce you to interval notation. Interval notation. Okay? I see just a couple people writing, so I'm hanging tight. Okay? This is interval notation. Okay? Instead of using the closed dot when the number, yes? I will in just I will go back in just a minute. Instead of using the closed dot, we're going to use brackets. So our brackets mean the number is included. The brackets mean the number is included. The open dot and the parenthesis means the number is not included. Now, you have got to graph this. If you don't graph it, there's a high likelihood that you're going to make a mistake on your interval notation. So, here we go. Instead of using the open dot to signify that 3 is not included, in interval notation, what am I going to use? Parenthesis. So I'm going to have a parenthesis at 3. I'm still going to go all the way up here. Now, if this keeps going and going and going and going all the way to the right, what do we hit if we go on forever at the right? Infinity. Okay? So I can go on forever to the right. And this is infinity. What happens when I go the other way? Negative infinity. Excellent. Negative infinity. So, I am starting. So I have graphed this, and I'm going to use the graph to write my answer in interval notation. Okay? When you are writing in interval notation, you always put the smallest number first. Sometimes that smallest number is negative infinity. Okay? But we start right here. Okay, so I've got the number 3, and I'm going to put a parenthesis around it because the number 3 is not included. And I go all the way to positive infinity. Okay? This is my graph right here. This is interval notation. Now, you are going to be tempted to skip the graph part. I would encourage you not to skip the graph part. Okay? Don't skip the graphing, because if you skip the graphing, you might make a mistake with your interval notation. Okay. Okay, here we go. And there's our interval notation. One thing that I want you to notice right here, all reals is infinity, negative infinity to infinity. Okay, so if you get an answer and your answer is all real numbers, that happens a lot more when we're talking about domain than it does for an answer. I just want you to realize that all real numbers is negative infinity to infinity. Okay? And this is the same screen you guys had up just a minute ago. Okay. now we are going to solve some equations or some inequalities. So the way that we're going to do that is we are going to treat that inequality sign the same way that we would treat an equal sign. Okay? So we are going to solve this, we're going to graph this, and we are going to write the answer in interval notation. Okay? We're going to solve, graph, and write the answer in interval notation. 3x minus 4 is greater than 8. First thing I'm going to do is add 4 to both sides. I'm going to add 4 to both sides. I'm left with 3x is greater than 12. Okay? I divide both sides by 3, just like I would with an equal sign. And my answer is x is greater than 4. X is greater than 4. So I have solved this. I have done the first part. I have solved it. Okay? I've solved. My next part is to graph it. So I'm going to put 0 right here, 2, and 4. I'm going to put a parenthesis at 4 because 4 is not included, and I'm going to the right. Okay? That is my graph. That is my graph. Now, I used an interval notation symbol, but the graph is not my answer in interval notation. Okay? From my graph, I start with whatever's smallest. If I am looking at my graph from left to right, I come to 4 first. Okay? I start at 4. 4 is not included, and I go all the way where? To infinity. Okay? I go all the way to infinity. Okay. Now, and I'll go back to these, but I'm running short on time, so I do need to go ahead and go to the next screen. Okay. Now, I'm going to do the same thing here. Now, this is the exception. This is the exception where we've got to do something a little bit different. I'm going to start solving this. I'm going to subtract 1 from both sides. I'm going to subtract 1 from both sides. I have negative 2x is greater than 4. Negative 2x is greater than 4. Now, I'm going to divide both sides by a negative number. That is when we do something different. Yes. When you divide or multiply both sides, and that both is important. It's got to be what you do to both sides. When you divide or multiply both sides by a negative number, you reverse, and if you say flip, that's fine. You reverse the sign. Okay? You reverse the sign. So here, I have x is less than. I had to reverse the sign. X is less than negative 2. X is less than negative 2. So here's my 0. Here's negative 2. Here's negative 4. Okay? At x is less than negative 2, I'm going towards negative infinity. Now, the number 1 answer that's incorrect that I get here, this is what I get, and this is wrong. I get negative 2 to negative infinity. That is the wrong answer that I get a lot of. Students start at the number and then they go to whatever infinity sign that they want to. That is wrong. You don't want to do that. You have to look at this number line starting at the left like you're reading, and you go to the right. So what is all the way down on the left? Negative infinity. Okay, and then I go to negative 2. Okay? You've got to look at the number line from left to right. And I'll have a lot of students say, but I got the right answer, I just had it in a different order. When you're writing it in interval notation, your order does matter. Okay? I really need to do 2 more problems for you. So I'm going to go ahead and go to the next screen. After class, if I need to go back, I can. Okay, here we're really doing the same thing, except we've just got a lot more information. Okay, so first of all, I'm combining like terms. So I have negative 3x and positive 5x. I'm combining like terms on the same side of the equation. So I have 2x minus 2. I just combined the negative 3x and the 5x. I have 8x and I have negative 9x. Okay, 8x and negative 9x is negative 1x minus 7. Now, one of the things that I want you to get in the habit of doing is move variable to the left. Move variable to left. Move the variable to the left. Okay? So I'm going to add 1x to both sides. If I subtracted 2x from both sides, I would still be okay and I would still be mathematically correct, but it makes the graphing a lot more difficult. Okay? It makes the graphing more difficult. Okay. Now I'm going to isolate my x by adding 2 to both sides. So I get 3x is greater than or equal to negative 5. I'm dividing by 3. I'm dividing both sides by 3, but this number is negative. Do I reverse the sign? No. I'm seeing people shake their heads no. No. I only reverse it if the bottom number, what I'm doing to both sides, is negative. I only do it then. So this stays x is greater than or equal to negative 5/3. Now, negative 5/3 is a little bit more than negative 2. Okay? Negative 6/3 would be negative 2. So we're almost at negative 2. I go up this direction. Okay, so my answer is negative 2 to positive infinity. Your infinity and your negative infinity will always have a parenthesis.
Okay, how did you get to negative 2?
How did I get to negative 2?
Yeah.
I'm not at negative 2. I'm at negative 5/3.
Well, I mean, yeah, but
Okay.
why is it?
Okay, so negative 5/3 is negative 1 2/3. Okay? Negative 5/3 is negative 1 2/3. And so that's how I got to negative 2.
Oh, you.
Yeah, so we
put it
could.
in a mixed number.
Yeah, you turn it into a mixed number. Okay? Now, I'm actually going to do this one at the beginning of the help session. I'll do it the entire one at the beginning of the help session. But for those of you that can't come to the help session, this will be recorded. If you want to take a peek at it, I'll probably do it on Wednesday as well. Wait. I got 1 minute. Okay? You have to distribute here. You have to distribute here. So you distribute first. Just like you would with an equation. Distribute first. Bye, guys.